Chain rule for the natural logarithm. So remember before, when we talked about the natural log of x, we had one straightforward derivative, which was 1 over x. Now, if we have a function more complicated than that, we have to go with the chain rule because now we have a composite function. Remember, if the natural log of x was the outside function, then the inside function is whatever is inside the argument of the natural log. So if we look at y equals the natural log of x to the fifth minus 3x squared plus 1, this is the same as if we had y equals the natural log of z, where z equals x to the fifth minus 3x squared plus 1. So we can see here that z was our inside function from our composite function. If we want to find the derivative of y with respect to x, we can find dy dz and dz dx and multiply them together. So let's look at these pieces. So dy dz means we're going to the function where y is our dependent variable and z is our independent variable. So that's y equals the natural log of z. When we take the derivative of that function, we get 1 over z. We also need dz dx. The derivative of z with respect to x, we go to this function over here, x to the fifth minus 3x squared plus 1, and we take the derivative of that. The derivative is 5x to the fourth minus 6x. Now if we want dy dx, the original derivative, we need to multiply these two derivatives together. So when we multiply them together, we get 1 over z times 5x to the fourth minus 6x. Now, we don't want a z in our final answer, so we're going to substitute back in what z equaled so that we have everything in terms of x. Additionally, since we're multiplying a fraction times a function, our function can multiply into the numerator. So that means our numerator becomes 5x to the fourth minus 6x, and our denominator is our z. So x to the fifth minus 3x squared plus 1. So the derivative of the original function, the natural log of x to the fifth minus 3x squared plus 1, is going to be 5x to the fourth minus 6x divided by x to the fifth minus 3x squared plus 1. Let's look at another example. Example 1. Find the derivative of y equals f of x equals the natural log of cosine x plus e to the x. So again here, we need to know what our z is. So z is the inside function. It's whatever is inside the natural log, which is cosine x plus e to the x. We're going to need dz dx, the derivative of that. Derivative of cosine is negative sine x, and the derivative of e to the x is e to the x. We also need to rewrite y with our z in it, so the natural log of z. And then the derivative, dy dz, is going to be 1 over z. When we multiply our two derivatives together, we get dy dx. So we have negative sine x plus e to the x, that's our dz dx, times 1 over z. But again, we don't want a z in our final answer, so we're going to substitute back in. And again, we can take our function and we can multiply it into the numerator. So negative sine x plus e to the x divided by, and now my z was cosine x plus e to the x. So again, you'll notice that I have one function over another one, just like in the previous problem. That's going to be the typical structure of our derivative answers, where the inside function of the natural log is going to end up in the denominator, and the derivative of that will end up in the numerator. So let's take a look at a shortcut we can use to make our calculations a little more efficient. If z is a differentiable function of x, then the derivative of the natural log of z is equal to 1 over z times dz dx. So again, If we can identify what z is, which is the inside function, we can use this formula to calculate our derivative with the chain rule. So here, my z, or my inside function, is going to be 4x to the 8th minus 2x squared. So my derivative, y prime, is going to be 1 over z, so 1 over 4x to the 8th minus 2x squared, times dz dx. So I need to find the derivative of z with respect to x. So the derivative here will be 32x to the 7th minus 4x. So 32x to the 7th minus 4x. You can leave your derivative like this if you'd like, but the convention is that we multiply the function into the numerator. So that looks like this: 32x to the 7th minus 4x divided by 4x to the 8th minus 2x squared. Example 3. Find the derivative of y equals the natural log of 3x. Now this may look simpler than the other ones we've been looking at, but this is one that often is computed incorrectly because of the 3. The typical wrong answer here is 1 over 3x. So if we had the natural log of x, the derivative would be 1 over x. But as soon as there's a constant in there, we have to use the chain rule. So we need to be a little bit careful here. So my z is whatever is on the inside, which here is 3x. My dz dx is the derivative of 3x, which is going to be 3. So now, applying our shortcut for the derivative, we know that we're going to do 1 over z, so 1 over 3x, times dz dx, which is 3. So here, the 3's are going to cancel, and we're left with a 1 over x. So again, the common mistake is that people think the derivative is 1 over 3x, when in reality, it's 1 over x. So you have to use the chain rule even if there's a constant inside the natural log. Let's look at another one. Example 4. Find the equation of the tangent line to f of x equals the natural log of x squared at x equals 1. So again, when we want to find the equation of a tangent line, we need the point value and the derivative value. So to get the point value, we need to plug a 1 into the function. So we're going to have the natural log of 1 squared, which is the natural log of 1, and the natural log of 1 is 0, which means the point that we're considering is 1, 0. So that's where our tangent line touches, and that's the point shared by the function and the tangent line. To find the derivative at 1, we need to use the chain rule to find the first derivative of this function. So here, our z is going to be x squared, which means our dz dx is the derivative of that, which is 2x. Our rule says we're going to have 1 over z, so 1 over x squared, times dz dx, which is 2x. So we can rewrite this as 2x over x squared. Notice that there's an x on the top and 2 x's on the bottom. So we can cancel 1 out, which will simplify into 2 over x, which means that the derivative at 1 is going to be 2 over 1, which is 2. So the slope of my tangent line is going to be 2. So now putting this all together, I have y equals 2x plus b. So the 2 again came from the derivative. And to find b, I'm going to plug in the point 1, 0. So I have 0 equals 2 times 1 plus b, which tells me that b equals negative 2. So finally, I get the result, and the equation of my tangent line is y equals 2x minus 2. So again, finding the equation of the tangent line is the same as what we did before, only now in order to compute the slope of the tangent line, we need to use a chain rule to find the derivative.